we measure a natural field on the Earth. The origin of this field is associated with various physical and chemical factors. In simple terms, it is as if the ground acts as natural battery, generating an electric current that can be detected and measured. But why use SP? Okay, the cell potential is a simple and effective technique, and has the three major advantages. First, since it's a fast method, I can cover approximately 3 kilometers per day. It's a slide method with a measure equipment. We do not exceed 5 kilograms. It is also a very economical method. We can purchase a complete kit for less than $500. As mentioned about cell potential can come from several sources, including electrochemical effect by, bueno, this is produced by electrochemical imbalance in the subsurface, mainly on the interface between fluids of different ionic composition, or between fluids and minerals. It is created by chemical reaction between materials with different oxidation and reduction potential. This is occurs in two common scenarios. Scenarios A, interaction between conductive minerals and groundwater, and oxidation reduction zones. These are common in contaminated environments, are with intense biological activity or presence of organic matter. This structure is analogous to what occurs in natural galvanic cell. A conductive mineral, such as pyrite, comes into contact with oxygen-rich water. The zone is the oxidizing zone. A redox reaction is generated on the surface of the mineral. For example, the oxidation of ferrous to ferrite releases electrons. This generates an electrical potential difference accompanied by an electrical double layer, as shown in the picture. Ions are distributed from the mineral into solution, and a spontaneous current flow visually and surface and occur. The effect thermoelectric, this phenomenon occurs when there is a temperature gradient within the subsurface that generates a flow of electrical current without need for fluids movement or direct chemical reaction. The impact, this effect in the laboratory, the coefficient usually varies between minus 0.25 to 1.5 millivolts per degree Celsius, with an average value of 0.2 millivolts per degree. This means that for a thermal gradient of 100 degrees Celsius, the ESP generated by this effect will typically be 20 millivolts. The topography effect is the result of moving away from the source. That is, we increase in the elevation and decrease in potential. Let's imagine the following. If we have a flat piece of land with constant water table, by topographic effect, the cell's potential will be constant due to the constant distance to the source. But if the terrain has elevation, okay, this diagram shows how the effect of topography moves us away from our source to the potential decrease as we ascend. The electrokinetic effect. This effect is caused by the circulation of fluids in a porous medium. It's not produced due to the presence of a positive charge on the rock surface, which by percolating the water into pores, dragging the loads with them, removing the loads, as a result decreasing the potential or increasing if it is the case of the rise of the opposite fluid. Note that we know the source of potential is unnecessary to know how to measure it. The most basic elements are a multimeter and two impolarizable electrodes. There are three main types of self-potential array. First, the leapfrog. The leapfrog consists of measuring with the electrons at constant pitch and constant separation, as shown in the image. We move at a constant distance and move both electrodes. And this way, consecutively, and fixed electrode is different. The fixed electrode array is based on having one fixed and one movable electrode. In this case, the fixed is the electrode A and the movable is the electrode B. As you can see, electrode B is the one that moves. Important, the fixed one will always be the negative one. And B will move at a constant distance from its appropriate position. If we reach the end of the cable and need to continue, we change the electrodes. In other words, mobile becomes fixed and fixed becomes mobile. The multi-electrode array consists of measure the potential difference between a base negative and multiple positive electrodes. The leapfrog, the advantage of the leapfrog is the small amount of the cable to be used, which allows us to better control its care. However, it is the one that accumulates more errors. The fixed electrode is the one in which the cable is most exposed to external factors. However, it is the one that accumulates the last error. The multi-electrode is a very fast method to obtain measurement. However, it is the most expensive. In the field, the necessary equipment is a little different. We need a GPS, a multimeter with the respective cables, a cable reel of at least 220 meters in length, a pair of electrodes, copper sulfide, and notebook with pencil. In the notebook, we will write down in 5 columns. The first is the distance of measure. Second, the GPS ID. Third, the resistance. The resistance is very important. This is used to evaluate the quality of the contact and will depend on the environment in which we are. If we have a good environment with moist soil, we will expect values below 100 kilo ohm. If we are in dry or very rocky terrain with values below 500 kilo ohm, it can be a good measure. At the column of SP, note the voltage or potential value, not forgetting the same, positive or negative. And if there is any particularity in the signal in the environment, we note in the last field. Okay, what to do before measuring? First, prepare the electrodes, remove the plug with the Cooper's rods, clean the Cooper bar. Well, for this, use sandpaper for the Cooper bars. Pour Cooper sulfate dissolved in water on the electrodes, and snap the electrode close. Evaluate the potential difference between them. If this between minus 0.5 and plus 0.5 millivolts, we can use them. We have different ways of measuring the potential in the field. The first is known as open profile. And in this, the first and the endpoint are different. Closed profile or closed or polygonal profile are those in which the start and end points coincide with each which other polygons. This is, for example, types of measure mesh. Meshing consists of having equidistance measurement in the form of a grid. The data acquisition direction can take several forms, including a zigzag direction, which for practical purposes is similar to an open profile. We have a four correction principle. The reference correction, log correction, loop correction, and hydrologic correction. The reference correction consists of correcting the effect of the change of electrodes, where the fixed one became mobile, and the mobile became fixed. It is based on linking the different section of a profile with another one, so that they all have the same reference. For example, for the first section, this is the reference. And for the second section, the reference is different. The reference of second section is not this, is this. This is done by adding the last SP value of the reference change to the following section until all sections are united. This is an example. This date is an example of the El Salvador. The first thing to do is to visualize the profile branch In addition, be clear about the direction of data collection. We know that the profile goes from ID 1 to ID 56. Making with a color will always help. We take the first section. As it contains the initial reference, we do nothing. The next one is different. The reference is not included in this section. It's necessary to add the value that in the change of electrode to the next section using the formula. The formula is speed ref is equal speed measure plus speed change value. The value, the last change is the minus 2 millivolts. The formula is effective for the section. It's the same processes for the rest section, the profile. We repeat the process for the rest of the profile consecutively. Okay. Second correction is this block correction. It is responsible for unifying the direction or data collection and ensuring that the variant everyone has the same baseline. It is also used to join uncorrected value to data already correct by the other correction and loop correction. It is only applied to closed profiles and is responsible for distributing the drift of the initial value with the final one and already correct value of the reference among all the points of the profile. Is usually the first volume with which the measure are taken and they try to take all the points in the same direction. Again, we verify the profile of range. It is important to note that the first and last point are physically the same, but they have a different value. Value, the ID 56 is different at 0 to value the first point. This will be known as drift. The objective is to distribute this drift among the points that make up the profile. Therefore, we need a point counter. That is the increment. For loop correction, we need block correction. Is ready. Drift the profile, the total points, and a counter. Already, loop is equal to block correction minus drift divided by total points multiplied by the increments. Round and ready. This is profile close, perfect. In this case, is the join a new profile. It's join on profile not correct, on profile correct. A new profile add to the correct polygon is forming polygon 2. The process is similar. Identify the starting point common to the correct profile. In this case, is the 56, 57 equal 19. The correct value is minus 36.3. This value, editing at the rest the profile, we obtain the drift between values correct and not correct of profile 2. We can and we perform the same process as the previous polygon. What is the new value? The correction hydrologic consists of performing a kind of block correction to all values with respect to a natural reference, such as a lake. This process is very, very similar. The last. Okay. As the lake theoretically has a value of 0 millivolt, we will use it is the new reference for the rest of the data. Okay. This is the fourth correction for the SP. I have other correction. This is the topographic correction, but it's not applied in all the case. The response of cell potentials, it depends on the origin. And in a hydrologic environment, if the water table is horizontal, as we go up in elevation, we decrease in potential. This case is the effect, the topographic effect. If we go up in elevation and the potential is constant, it is because the water table is always at the same distance from the surface. This. In the case of faults or fissures, we will have sums of preferential descent as a result of minimum speed. This is the case of the Paleo Valley. And the case the thermal is important the attention for the case, and this since it is same or very same, but the difference is is the source. The source and hydrogeological is the water table, but hydrothermal is a source of hot. The self potential in volcanic environments is similar shades of the hydrothermal. The response of the potential will fields W behavior. This when crossing the volcanic building. Let us return to the case we have seen previously of the topographic effect. In this case, we do not have any source of energy that makes the shares rise. However, an active volcano has enough energy in this interior to vaporize the water and allow it ascend, which consequently allows the drawing to charge to the surface, increasing the self potential with ascend the elevation. As shown in the pictures, per zone is hydrological zone, descend the spin, ascend the spin for the hydrothermal systems. In this case, a similar case hydrothermal and hydrogeological. This zone is similar for the source is constant the surface, and this the sun the potential for the increase the potential. Self potential emitting environment. Why emitting? Sensitive to conductive bodies, sulfides, graphite, economical, fast, and not invasive. The self potential has its origin in meaning. One of the advantages of the method is practical and economical, fast, non-invasive, and sensitive to conductive body method. However, we cannot separate the source of self-potential when measured in a meaning environment. The predominant source of these are electrochemical source due to the redox effect and electrokinetic source to the movement of charge through a porous medium. The response of the self-potential to a conductive body is a negative maximum of the signal. One of the experimental characters are large amplitude anomalies, minus 100 to minus 1000, and is stable over the time. It is inevitable to observe the influence of the other potential source, which we call background noise. One of the first things to define is what type of measurement we will do. Open profiles in parallel and traverse arrays. As an advantage, we have this field, and that allows us to take a first look at the geometrical of the anomalies. The closed profile, we can use existing routes to increase efficiency. We have the possibility to generate good resolution maps and create a better idea of the range of the bodies. For the mesh, it is the one that gives me the best definition. However, it is the slowest of the three measurement arrays. Therefore, we can divide into three phases, regional phases, allow we to explore large area in search of anomalies and have the first identification, in addition to obtain the potential vector. As is name for the delimitation phase, is provides close around the anomalies detect, measure step, the same with the last, the 20 meters. As the same indicates, the limit the area of influence of the anomaly. Regardless of the array, it is important to consider a good reference that is outside the area of influence of the anomaly. For mesh, says this detailing phase, a fine mesh of between 5 to 20 close to the anomaly. It explores and identifies detail the range and amplitudes of the anomalous body. For the parallel profiles, to work with parallel profiles, the first step is located an intercept point. This is explore and identify the type of anomalies. We use the profiles open, and we have 2 points of view for analysis the parallel profiles. The first analysis is for the profile by profile treatment. It is easy to detect the minimum and maximum potential. The correction necessary for this analysis is reference correction, block correction, and hydrologic correction. For the second point of view, the treatment for moving for linear open profiles is to consider the intersection of the profiles as nodes, so that polygons form in the area. The correction necessary for this analysis is the reference correction, block correction, loop correction, and hydrologic correction. This is necessary for generate the maps of cell potential. In hydrological case with preferential infiltration, negative anomalies can occur. But what is the difference between these negatives and those associated with a body? Okay, the first difference is the size and stability over the time. For the hydrological anomalies, the size is plus size. Infiltration anomaly correspond to large size. However, they vary with the climatic season. In other words, is not over the time. And the anomalies for the meaning is anomaly plus punto, and the large of the anomaly is plus small. Okay. Thank you for your attention.
Okay, excellent explanation. And Diego, I would like to know. I'm very interested in. I'm very interested in the way you process the SP data. Can you start from the notebook? So what stuff that we need to note in the field before that? I only see the GPS ID and the what we call that the resistivity, the voltage, and what other things is the distance. And what is the last one? Can I see the notebook, please?
Okay,
Yep.
one moment.
The field note, sorry. Excellent, that's one. Yeah. So the distance, sorry, yes, the distance and GPS ID. So if we are in a like so we have loop one and loop two and loop three, stuff like that. So loop linked to another loop, linked to another loop. So what is the distance refers to? Is that to the first point or to the first space in the day one, or what kind of distance?
Okay.
Yeah.
The reference point.
Yeah, so the
Uh,
distance, yeah, the distance what so if we have like say loop two linked to the first loop, so what is the distance refers to?
okay.
Yeah.
Depends of the thing on the terrain, but uh, normally if the terrain is good, it is a flat.
So I think,
Maybe
yep.
possible, even every 300 meters.
Okay, cool. So the distance is like 300 meter in the difficult terrain, but so it's like so the distance. So what I mean is that so in the second loop, say we have like what loop one and loop two and loop three. So in the loop one, the distance refer to like the distance between the points we are measuring now and the first point, right? And in the second loop, so in the second loop, the distance is like the point we are measuring right now and the first point as well. So how do you define the distance? Sorry. Yep, that's excellent. Yeah. That would be nice. Yeah, yeah. The distance of the second loop. Yeah. So how do you define the distance of the second loop? How do you define like the second point of the second loop says like the distance is like 2 times like 300 meters from the first point in the second loop or stuff like that. So how do you define the distance in the SP loop?
Uh, what specific distance?
Specific distance. So like the one you have in the cell E, in the column E. So it's distancia. So can you go to the second loop? So
Ah,
yep,
okay,
yep, 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 yep.
okay,
Excellent.
okay, okay. Sí, sí. Okay.
Um, Excuse me, I help Diego with this part because English is not his first language.
Oh. Yeah, okay, cool. No problem.
I will be the translator.
Yeah, yeah, yeah.
Ah, okay.
Sweet.
Thank you.
Ok. Él está
Eh,
preguntándote, digamos, que cómo defines la distancia para el segundo loop.
Ok, en el Excel tenemos distintas distancias. Esta distancia que está siendo visualizada se
Mhm.
conoce
Okay.
como distancia
In
de
the
campo.
Excel, we have different distance. The first distance is the field distance.
Mhm.
Esta distancia que está aquí presente depende del terreno en el que nos encontremos.
That distance depends on the terrain in that we are.
Mhm.
Si estamos en un terreno que es plano, es muy llano, podemos tener unas distancias muy grandes.
If the terrain is flat, we could have really large distance.
Mhm.
Eh, el color amarillo que está en el diagrama representa los cambios en el electrodo.
The yellow color in the diagram represents the change in the electrons.
Y esta distancia, como repito, depende del terreno. Ahora bien, para
And
definir la distancia
in
de un
that
perfil,
distance, okay, in that distance depends always in the terrain.
Mhm.
va a depender del terreno y de lo que estemos buscando.
Okay, it depends on the terrain and what are looking for.
Por ejemplo, en un volcán, el primer polígono de referencia muchas veces es el anillo.
For example, in a volcano, the first loop is it's in the ring.
Pero la intención es que los polígonos entre más pequeños,
But the intention is if the polygon becomes small,
Mhm.
me van a dar más detalle al momento de la interpolación.
these small loops will be give me more details.
Lo que buscamos es un equilibrio entre tamaño y tiempo.
We are looking for an equilibrium related to time and ¿qué era lo otro?
Tamaño y
Tiempo
tiempo.
and time and size.
Okay, cool. So, okay, yeah, excellent. So I see there is like in the row number 11, there is like a 20. I think it's like 20 is the distance between the ID 20 and the ID 10 or stuff like that.
Pregunta que si la distancia, digamos, es, digamos, la del ID 20. Can you repeat, please?
Ok, fue un detalle de que fueron actividades hechas en distintos días. Entonces, esa distancia de campo representa el tamaño o la longitud que se estaba dando desde que se midió hasta que se cambió la referencia.
Okay. That change represents different days of fieldwork.
Ese es el tamaño de las secciones, no del perfil.
That is the size of the section, not of the profile.
Mm,
Para el perfil existe otra distancia que corresponde a una distancia acumulada.
For the profile, exists other distance that corresponds to the distance, the accumulate distance.
okay, making sense. Yeah, okay, makes sense. Also, there is reference. Yeah, so SP has like a reference correction here, and the other one is drift corrections and what else? Drift and I do take note like block corrections, drift, reference, and hydrologic corrections. So for the hydrologic corrections, do we need to always have it, or it's like just when we have like any lakes? Because in the place we are about to do the field excursion in the South Malang area in East Java, we do not have any lakes or river or any like sea stuff like that. So we do not have any standing water body. So we cannot have a hydrologic correction there. So what is your what we call that? Your strategy in converting the SP from relative voltage measurement into an absolute voltage without the hydrologic correction.
Okay, aquí ellos
Yep.
mencionan que no tienen, digamos, lagos o lagunas o algún cuerpo así. Entonces, ¿cómo es la estrategia si no tenés esa corrección?
Ok. La corrección hidrológica es si tenemos la disposición de un medio natural, un medio hidrogeológico o un medio
Okay.
hidrológico.
The hydrogeological correction is only if we have a geological body of water or lake at the lagoon or lake.
En el caso de no tener,
But if we don't have any body of water,
buscaremos una zona que no esté presente dentro de la anomalía.
if we don't have any body of water, we are looking for a zone with a zone outside the anomaly.
Es decir, vamos a buscar el punto que esté más alejado de esa influencia.
We go to a point really far to the anomaly for this point.
Okay. From the anomaly. So okay, that would be quite difficult uh because we do not have any like we do not have any idea on where the anomaly will be located. And also like the survey design of our future work is mostly like in a grid in a mesh setting, and I think I don't know, but we will be doing stuff like fixed base in that case. So I do not know if we can do any correction that resembles or that looks like hydrological corrections there. Maybe we can have like block corrections and drift corrections, but what is that? Block correction and drift corrections and maybe a reference correction, but we cannot have stuff like hydrologic correction. So is it still all right? In your opinion?
Okay,
Yeah.
mencionan que ellos donde están, bueno, no saben dónde es, digamos, está la anomalía, como lo que estabas explicando. Entonces, en este caso, bueno, mencionan que, ok, está bien, tienen las otras correcciones, pero con esta corrección hidrogeológica, entonces, ¿cómo sería? Y también mencionan que lo van a hacer como una mesh.
Ah, ok. En el caso que nosotros desconocemos, es nuestro primer acercamiento desde, al área, lo que tenemos que hacer es tomar las medidas, hacer los tres procesamientos,
Okay,
referencia, bloque y cierre.
okay. If we don't know about the anomalies or the thing we are looking for, we go to the field and take the the measurements and then do the different correction. What correction? ¿Qué corrección?
Corrección de referencia, bloque y cierre.
Reference correction, block correction, and the other one.
Eh, el detalle es que cuando se termine las correcciones, es decir, que yo identifiqué una anomalía aquí, por ejemplo, y pasé mi
Okay.
perfil por todo esto.
Okay. When we finish the correction in the diagram, you see a circle, and the circle is the anomaly. In this case,
Ok,
if you you measure on the anomalies, continúa.
ok. Atravesemos la anomalía. Yo voy a observar la influencia de ella, independientemente. Ahora, ya
Okay.
que yo vi la anomalía, yo puedo
Okay.
definir, ok,
When I measure on the anomaly, when I process the data, I will see um, hmm, I will see the influence of this anomaly in the data.
ok,
Continúa.
independientemente, el efecto está. ¿Qué es lo que va a cambiar? Es la referencia que tome. Es decir, que yo puedo, ya visualizando la anomalía, tomar esta referencia aquí, que es la más alejada, y yo ya la vi.
Okay, in this case, when we identify the anomaly, we select the reference for the hydrogeological correction, and we select uh, the point more far from the anomaly.
Lo que hace la referencia hidrológica es básicamente cambiar la elevación. Es decir, que si yo tenía una señal de ese sentido, la va a cambiar a ponerla más abajo, simplemente.
The
Pero las anomalías
hydro
permanecen.
the hydrogeological reference only change the elevation of the data, but the anomalies will be the same.
Sense.
En
Excellent.
el caso que ellos buscan o van a hacer una mallada, una mesh,
Ujú.
quiero ver, mesh, lo ideal es que tengan los subpuntos de la mesh.
Mhm.
Okay, this is an example for the mesh.
Al terminar sus datos e identificar la anomalía, busquen un perfil que los aleje de la anomalía, si es el caso.
¿Cómo así que lo buscan?
Ok, ellos toman sus primeros datos, identifican su anomalía.
Okay,
Ellos ya lo
you
saben.
you will take the different point of your mesh and you
Mas-
will find anomaly.
Mhm.
Ok,
And then, continúa.
ok, entonces ellos lo que hacen es hacer una corrección de bloque con un perfil que se aleje de la anomalía, si es
Okay,
necesario.
okay. If you find the anomaly, you are the. ¿Qué corrección dice? ¿Qué corrección?
¿Cómo?
¿Qué corrección dijiste que es la que van a hacer? Bueno,
Bloque.
when you, okay, you finally uh, have the idea of where is the anomaly, you add other profile to your mesh. like the line in red in the diagram. And then you correct for block.
Okay. Okay, making any sense? Yeah, makes sense. Okay, let's see to the chat room. There's another questions from Yunus. The first question is, what do you think is the causes of the drift? Is it like instrumental or geologic or like maybe like space related? I'm assuming like it is like coming like solar storms, stuff like that. And the second question is that what if the spacing of the measurement cannot be consistent, such as if there is a steep terrain, or do you need to use horizontal distance or slope distance? Slope distance means like the distance along the topography, and the horizontal distance means the distance as in the map. So we do not really taking care of the topography. And if extreme conditions, if the planet point takes too much time than the previous, how to do the drift corrections? So that's the two questions from Yunus to you. Um,
Ok, la primera pregunta es que, ¿qué es lo que piensas que causa el drift? O sea, si es algo instrumental, geológico o relacionado con el espacio.
Ok, el drift es originado por muchas fuentes. Tenemos desde cambios en la temperatura,
Okay. And the drift is because different sources, change in temperature,
eh, la influencia de la luz solar,
the sunlight influence,
humedad, cambios de humedad en el ambiente,
uh, change in humidity in the environment,
lluvia
rain,
y desviaciones o desgaste de los electrodos durante toda la misión.
and due to the electrodes, because I don't know how to say, but the
Además,
liquid inside the electrodes um, could be finished, and you need to um, take care of the electrodes.
ok,
Mhm.
además también hay un efecto de ruido por las pequeñas rocas. La distribución de las rocas que va a cambiar de una medida a otra, de las pequeñas.
There are some noise related to the small rocks because they have some small influence and could cause this drift.
A este le conocemos como ruido litológico
This is lithologic noise.
y ronda alrededor de los 10 milivoltios. Esto ha sido observado experimentalmente en campo.
And that noise is around 10 millivolts. Okay.
okay.
La segunda pregunta dice que ¿qué pasa si el espacio no es consistente con lo de los 20 metros? Por ejemplo, dice, si no tenemos un terreno horizontal, o una distancia horizontal, o una distancia así como con pendiente. Y en una condición extrema, dice, y podría, digamos, tomar demasiado, o sea, como que tienes tomar demasiado espacio entre el punto con el anterior. ¿Cómo sería en ese caso la corrección por drift?
Ok, realmente no hay mucho problema. Depende también de cómo vamos a nosotros a tomar nuestra interpolación y también una consideración propia del terreno en el que estamos.
It depends on or interpolation, and it depends really on the terrain we are.
Normalmente no vamos a estar, o raramente vamos a estar en un terreno totalmente llano en
It's
el que
not
los 20 metros
usual.
sean exactos.
It's not usual to stay in a flat terrain with a consistent 20 meter per point.
Pero Nosotros esto lo podemos compensar con una técnica conocida como doble interpolación.
But we could compensate this problem with another technique called compensation.
Esta consiste, bueno, esta la hemos usado nosotros principalmente para polígonos,
This technique is usually used in polygons.
en el que la distancia rara vez es constante cada 20 metros. Siempre hay alguna variación de unos 3, 2 metros.
In this case, the distance is not consistent to 20 meters. The distance could vary 3, 5 meters.
La técnica consiste en realizar una primera interpolación al de que sea que alcanzar abarque al menos unos 3 puntos dentro del polígono, es decir, aproximadamente unos
Uh,
5 veces el paso de medida, de 5 a 10 veces el
Repites?
paso de medida.
Repite, por favor.
Ok, la primera interpolación
The
consiste
first,
en una interpolación que corresponda a 5 veces a 10 veces el paso de medida, dependiendo la región, la zona.
okay. The first correction corresponds to the correction that you take 10 times or 5 times the measuring size
Ok,
in the
esto lo
zone.
hacemos mediante la interpolación de Kriging.
We use Kriging interpolation for this.
La interpolación de Kriging, la ventaja que tiene es que puedo ver la desviación estándar de mis datos.
The advantage of Kriging interpolation is because I I see the standard deviation of my data.
Y puedo corregir para la primer interpolación en base a ello.
And then I correct the first interpolation based on the standard deviation of my
Sí,
interpolation.
pero tomar en cuenta que si la separación que hay entre un perfil y otro es muy larga,
Is the distance between one profile to other profile is too large?
claramente esta parte central no me sirve.
This central part of the study doesn't work.
Ok, esto es el primer paso de la doble interpolación.
This is the first step of the double interpolation.
Lo que sigue es tomar los datos interpolados más los datos reales y volver a
Then,
interpolar.
explica otra vez, por favor.
Ok, tomar los datos interpolados con estos por 10 veces el paso de medida.
Okay. We take the data and interpolate the data, and then,
eh, y añadir los datos reales y realizar otra interpolación bueno, a 2 veces el paso de medida.
then add to this corrected point, to this interpolated points, the first data, and then, ¿qué es lo que mencionaste?
¿Cómo?
¿Qué mencionaste después de añadirle los datos anteriores?
Ok, y volver a interpolar, pero esta vez a 2 veces el paso de medida.
And then re-interpolate, but this time with two times this is the space in between the measures.
Con esto lo que estamos haciendo es reduciendo los artefactos artificiales en la interpolación.
This reduce the artificial uh, artifacts.
Oh, okay, excellent. Okay. Yeah. Is there any more questions from the students or Anybody else?
Excuse.
Yep.
Okay. Thank you. Want to ask a question, Mr. Lutfian.
Mhm.
My name Yuda. I'm from Universitas Pembangunan Nasional Veteran Yogyakarta. I want to ask about how to determine the best technique, fixed base or leapfrog or multi-electrode in field by the target. How to determine the best technique from the target that we explore. I think enough, Mr. Lutfian. Thank you.
Ok, menciona de que cómo decides cuál es la mejor técnica de los que habían aquí, como leapfrog, la otra, bueno, las otras que mencionaste, dependiendo, digamos, de lo que vayan a buscar.
Mi recomendación es que... espera. La técnica que es más efectiva en todo terreno es la de electrodo fijo.
¿Cómo la pusiste en tu diapositiva?
¿Cómo?
¿Cómo se llaman? Ok.
Pixel.
The most effective technique is fixed electrode.
Okay.
Electrodo fix. Esto es debido a la distancia que se alcanza a cubrir en poco tiempo.
And this is because you can obtain more data in less time.
Además, que reducimos el ruido o los errores de estar cambiando un electrodo respecto a otro.
And you reduce the noise and the errors due to the change of the electrode.
Por ejemplo, en leapfrog,
For example, leapfrog.
la acción de este movimiento está
The action of
induciendo
that,
errores.
the
o-
action
o
of that
induciendo.
movement induce errors.
Mientras que en el electrodo fijo, sí tenemos ese tipo de errores similares,
While in fixed electrode, yes, we could have that errors,
pero el error de cambio de posición se da cada 100, cada 200 o cada 300 metros.
but the error because the change of position will be at 10, 100 meters, 200 meters, 300 meters.
A comparación del leapfrog, que es cada 20 metros.
And in leapfrog, the error is at each 20 meters.
Algo que es importante mencionar es que una anomalía va a ser vista tanto por si lo hacen con leapfrog o con electrodo fijo.
Something important is an anomaly could be noticed if you use fixed electron technique or leapfrog technique.
Sin embargo, la calidad de la señal va a ser distinta.
However, the quality of the signal will be different.
Como tal, si tienen la posibilidad que prueben ambos métodos y comparen en el mismo lugar.
If you have the possibility, you could use both methods and compare.
Diles que buscaré una práctica que nosotros hicimos en la que comparamos directamente el leapfrog con electrodo fijo
¿Se los enviará?
y se le enviaré al correo.
Okay, he said that he will looking for a practice and he will send to you.
Okay, thank you. Excellent.
So what I'm really catching to is that the leapfrog method is better over the fixed electrode, isn't it?
Pregunta que si es mejor el leapfrog o el fijo.
Electrodo fijo.
Fixed electrode is better.
So the fixed electrode one is better over the leapfrog one, isn't it? I see.
Yes.
Excellent. Okay, cool. So I'm really interested in the multi-electrode method. I mean, I do not really planning to do it in the future, but I'm interested in how is the field, how is the field practice of the multi-electrode method? Is that like, I don't know, how do you describe the field practice of multi-electrode method?
Es sobre el método de multielectrodo, que, o sea, bueno, ¿cómo es el campo en el que se puede aplicar?
El detalle con el multielectródico, pues puede ser aplicable en todo.
You could use multi-electrode method in all the environments.
Sin embargo, la mayor dificultad que tiene es el tema del equipo,
But the disadvantage of this method is the equipment.
porque necesitan un multímetro que tenga muchas bandas, muchos canales.
But because you need a multimeter with a lot of bands or channels.
El otro detalle es que los electrodos buscamos que sean los más similares posibles.
The other detail is with the electrodes, we are looking for similar electrodes with
Esto
the
para,
same.
esto para evitar
Okay.
error
Mhm.
propio por instrumento.
Okay. This is for avoiding the. ¿Qué me dijiste?
Es para reducir el error instrumental.
This is for reduce the instrumental error.
En el caso, si tenemos un arreglo multielectródico, tendríamos que tener todos los electrodos muy similares unos entre sí.
If we have a multi-electrode array, we need a really similar electrodes.
Una de las cosas por qué nosotros lo vemos un poco como una desventaja
Okay, one of the things we consider this as a disadvantage
es que nosotros creamos nuestros propios electrodos.
is because we create our own electrodes.
Entonces, garantizar las mismas condiciones para todos se vuelve más complejo.
And have the same condition for all the electrodes is difficult.
La metodología, por ejemplo, enmayado, es bastante más rápida con este tipo de arreglo.
For a mesh, the methodology is more fast with this method.
Pero al final es cuestión de ahorrarse unos cuantas horas simplemente.
But at the final is you only spend less hours is the difference.
Y este tipo de arreglo es principalmente utilizado para pruebas de abatimiento o pruebas de bombeo en hidrología.
But this method is really used in hydrologic.
Okay. Okay. Okay, I see. Okay. I think the multi-electrode method is similar to fixed base methods like maybe in Spanish like me parece que el multielectrodo es parecido al de base fija, solo que cambiando canales. That's what I'm thinking of.
No, perfect. Yes, it's similar.
Similar, excellent, proper. Okay.
Además, este tipo de arreglos reduce significativamente el error por cambios de electrodos.
This type of arrangement reduce the error due to the electrodes.
Excellent. Yep. Is there any more questions from students or any other people attending here? Hmm. Okay, if not, I would like to ask another thing. So yeah, I'm curious on the Excel file for doing the corrections or the data processing for leapfrog, multi-electrode, and fixed base method. Can you show the formula for each method? So for the leapfrog, this is the Excel formula, this is the Excel columns, and this is the yeah. So this is the data that we want to have, like the voltage, and this one is Excel for the multi-electrode, and this one is Excel for the fixed base. Can you show us on about the Excel file and explain the formula on how to do the corrections?
Okay,
Okay.
Yeah.
all correction is for a fixed electrode.
Oh, fixed electrode.
But we working únicamente.
Uniquely,
Nosotros trabajamos únicamente con electrodo fijo.
we uniquely work with a fixed electrode.
Fixed electrode. Okay. Okay. So how about the one that is for like the leapfrog one? So the Excel for the leapfrog methodology. So do you have any of them here?
Si tienes, digamos, información sobre, bueno, tienes un ejemplo del Excel para el leapfrog.
No, pero son lo mismo.
No, but it's the same.
Okay.
Me
It's the same.
explico. El leapfrog lo que me está diciendo es que estas secciones no son de 180 a 200 metros.
Okay, leapfrog only tell me that this section are not ¿de cuánto dijiste?
De 100 a de 200, de 180 a 200 metros.
Are not from uh, eight- 80 meters to 180 meters.
En este caso, leapfrog lo que me está diciendo es que estas secciones son
In this
mucho más
case,
pequeñas. Son
leapfrog
de 20
tell
metros.
me that these sections are more small, are around 20 meters.
Mhm. Okay, cool. So, okay, cool. Thank you so much. Okay. So wait, I'm currently like making some what we call that. So wait. So yeah. So say I want to ask about the procedure of like doing SP in a grid. So stuff like I'm gonna share my screen. Can I share my screen, please?
Quiere mostrarle su pantalla.
¿Cómo?
Quiere mostrarle su pantalla.
Ah, ok.
Yeah. So yeah, stuff like I'm thinking about doing SP in this kind of setting. So um if the SP is like in a grid setting like this, is it better to use a fixed base or a leapfrog one? I'm thinking more of
Okay.
like doing a leapfrog one, but I'm not really sure.
Ok, dice que en ese caso ellos van a trabajar con una mesh, entonces, ¿qué es mejor? ¿El leapfrog o el método del electrodo fijo? Él piensa que el leapfrog.
Electrodo fijo, mire.
Electrodo
Ya le
Uh,
explico por qué.
the best option for this case is fixed electrode.
Ah, ok, inclusivemente,
Okay, sure.
ellos podrían trabajar con, también tomando, por ejemplo, el primer punto como referencia, como base,
Okay, you could work taking the first point like a base,
Mm-hmm.
y de ahí seguir un perfil en forma de zigzag.
and then follow a profile in the shape of zigzag.
Es decir, no. Ah, the first, the last.
The first,
First point to the last in in that line.
mm-hmm.
Ajá. Y luego, ajá.
Uh-huh. And then this
Yes.
one?
It's possible.
It's
Possible.
possible.
Okay.
El detalle con la mesh es que lo pueden considerar de muchas maneras.
The detail in the mesh is you can consider with several for with several ways.
Lo pueden considerar como un solo perfil abierto
You can consider this like a one open profile
Mm-hmm.
o como lo que le está haciendo, múltiples
or
polígonos cerrados.
or or like you are doing in the example like a multiple polygons.
Okay. So in the
La ventaja,
in the open loop, how do you do the open loop one? I mean, I only have the imagination of this like multi-polygon. How do you do the open loop one?
¿Cómo debería estar del abierto en este caso?
el abierto sería partiendo del primer punto,
Starting from the first point
Mm-hmm.
a la derecha,
to the right,
The right,
down,
down,
left,
left,
down,
down,
right,
right,
left,
left,
down,
down,
and right.
right. Okay. So the final point here is different from the first point. So I mean,
Wait,
yeah.
it's correct. Ah,
Oh,
en the mesh es posible trabajarlo como un perfil abierto. Sin embargo, se
in the
compensa de
mesh,
una y se pierde de otra.
in a mesh it's possible work with like a open profile, but have advantage and disadvantage.
La ventaja es la rapidez
The
de
advantage
procesado.
is because it's really fast for processing.
mm-hmm.
El problema es la deriva.
The problem is the drift.
Mm,
Si él lo trabaja como lo estaba mostrando al principio, es decir, el primero cerrado, luego cierra y cierra,
If you
reduce
will
significativamente
work
la deriva.
if you will work with your first example, you reduce the drift.
Okay. So okay. So how can I account for the drift? Like if we have no water body like lake or sea, so how do we know the drift?
O sea, can you repeat, please? Sorry.
Okay,
No, Lucian, can you repeat the question, please? Sí, creo que no le entendí la pregunta, pero ¿me puedes preguntar que lo repita, por favor?
Uh-huh.
I don't know what happened.
Oh yeah, so
Diego,
yeah, sorry. So it's like so in the open loop method, so we go to the right from the first point and then down, and then after that going to the left and then down to the right, and after that the final point is different from the first point, and so we have a drift effect, but how do we know the drift effect between the first and the last point here?
okay.
Mhm. Or
Diego,
maybe my illustration for the open loop method is wrong, or can you give me corrections?
ok. Ah, él pregunta que si en este caso, o sea, ¿cómo sería con la corrección por la deriva?
ok. En este caso,
Cuando digamos
con
tenés
un
un
perfil
perfil
Mhm,
abierto.
mhm.
no se puede hacer corrección por deriva, no se puede hacer corrección de cierre. Solo puede ser corrección de referencia o de bloque, si
We,
es que en algún punto hay algo que ha sido en una dirección distinta.
we cannot do correction for the drift,
Mhm.
only for the reference. And is sometimes happen and you change the direction of one of the direction of your measurements
Mhm.
in this open profile, and you will do the block correction.
Mi recomendación,
Okay, my recommendation. Ujú. Diga,
Yep.
ok,
Good.
ah, es que lo trabaje como perfiles cerrados.
que no. Hola,
Hola,
Diego, que no lo trabaje
¿sí?
como
¿Me
perfiles
escuchas?
cerrados. Sí.
No, no, que lo trabaje como perfiles cerrados.
My recommendation is for this mesh with polygons.
Okay, cool. Thank you so much. Yeah, you can share your screen again. I'm stop sharing. There is another question from Yunus. Is that can we use this method to inspect corrosions in buried metal pipe? So the logic is that a metal pipe will have a chemical redox reactions between the pipe and the soil. And also, is there any requirement of the small electrode to measure the small changes that might come from the corrosion? So all these corrosions have more like stronger anomaly than the anomaly coming from the background, yeah, geology or stuff like that. So yeah, that's from Yunus.
Ok.
Mhm.
La primera
Ok,
pregunta es, dice que es, ¿las tradujiste? Bueno, la primera
la
pregunta
primera,
es que si, digamos, con este método podrás inspeccionar la corrosión así como en una tubería metálica enterrada.
teóricamente sí, dado que se está dando un efecto redox, actuando como una celda galvánica.
Ok. For the first question, the response is theoretically yes, because we have a redox reaction. Mhm.
Sobre requisitos, sí, posiblemente, pero más que todo el tema de capacidades del multímetro, que tiene que ser un multímetro de alta impedancia,
Uh,
y muchas veces algo que puede influir es el área de contacto.
okay. We need a high impedance multimeter. And lo otro,
El área de contacto del electrodo
uh, and the areas contact of the electrode
y el paso de medida.
and the step size of the measures.
Una tubería enterrada que se está oxidando va a tener una longitud mucho más pequeña que 20 metros, normalmente.
In this case, buried metal pipe, the size is less than, menos de que cuánto?
20 metros.
Less than 20 meters.
Okay, cool. Thank you so much for your answer. And I would like to ask some other, maybe two other questions for you. This is the self-potential. Can you see? Can you see it? I don't know if you can see it. View speaker, multi-speaker. So I don't know if you can see it, but this one is the self-potential electrode that we have in our department, and it have a sunken contact. So the contact is not like um, the contact is not it's not like it's not like appearing. It's not like it's sunken. So it's inside the a bit inside the pipe, and the problem is that this electrode cannot be refilled. So the content is just like this from the beginning. So do you have any suggestions on whether this contact is this electrode is usable? Like the contact is sunken and the copper sulfide cannot be refilled. So is it fine for field measurement? One, and two, do you have any suggestions on whether we should? So this is the box where the sorry, it's a bit like blurred. I need to deblur this one.
Okay,
Okay, cool.
menciona que
So this is the box where the box where we store the electrode. So do we need to fill this box with copper sulfide and then put this electrode inside so it keeps the electrode like wet? So do you have any suggestions on about this electrode? Thank you so much.
ok.
Mhm.
Menciona ahí que, bueno, ellos tienen ahí unos electrodos a los que no les han como rellenado de nuevo porque, bueno, los tienen así, digamos, con ese líquido desde el inicio que los tenían. Entonces, si tienes alguna como sugerencia, o si esos electrodos son buenos para, bueno, medir en el campo.
Ok. Ah, si no mal recuerdo, o si no escuché mal, eran electrodos de zinc.
Sí, creo.
Ok. Ah, este tipo de electrodos, con lo que pueden verificar la calidad, es midiendo la resistencia que hay entre el conector y la superficie porosa para
Espera,
verificar la calidad.
¿me lo repites?
Ok. Puede verificar la calidad. No,
You
no es
can,
necesario que,
¿cómo?
no es necesario que lo rellene si la calidad del contacto y la respuesta del electrodo sigue estando bien.
It's not necessary to refill is the quality of the contact It's good.
Puede evaluar la conductividad, o perdón, la continuidad, si evalúa desde el conector y
You
hace
can
contacto con la
evaluate.
superficie porosa.
¿Me lo repites, por favor?
Que puede evaluar la resistencia o la
You can
conductividad
you can evaluate the resistance or the conductivity.
del propio electrodo si pone el multímetro en el conector y el otro electrodo del
Is
multímetro a la base,
okay.
a la superficie porosa.
Okay. You could. Es que me dicen mucho. Ah,
¿Cómo?
No
es que
problem, no problem. I could
intento.
understand a bit of it. So it's like to check the connection, the resistance between the electrode, isn't it? And after that,
Yes.
yes, exactly. And after that, as long as the voltage difference is less than 0.5 millivolt, it will be fine, I think.
Me pregunta que si es menor a 0.5, ¿están bien, digamos, esa diferencia?
Ok, ese caso es si va a utilizar los dos electrodos. La diferencia de potencial entre los dos electrodos conectados uno a otro debe estar en ese rango.
If you will use two electrodes, the difference between measure the two electrodes needs to be in that interval.
Okay, cool. Okay, cool. So it's the difference between the voltage is less than 1 volt. Sorry, how many volt?
¿Te cuenta?
Minus 0.5 plus 0.5.
0.5. Okay, cool. Excellent.
Puedes decirle que al final del día, esta diferencia, con que no sea extremadamente grande, se va reduciendo con los cambios en los electrodos.
Okay, this difference, at the end of the day, this difference will reduce when we are changing the electrodes.
Por ejemplo, si en la primera llevaba más 5 milivoltios, por ejemplo,
If in the first you have a plus, ¿cuánto dije?
5,
5 millivolts.
cuando hago el cambio de electrodos,
When
eso
I
va a
change the
cambiar de polaridad.
electrodes, that's change the polarity.
Okay. Okay, cool. Understand. Okay. So now it's a bit like 5 minutes to 9 a.m. in Indonesia, and it's getting very late as well in El Salvador, I think. So finally, I would like, can we be sent the Excel file and like the example SP file for us to exercise so we can what we call that, we can learn on how to do proper SP data processing with ourselves, with our students. Is it possible?
Pregunta que si, digamos, podría como proporcionarles como el Excel para que ellos puedan practicar y estudiar cómo hacer la corrección o enviarles algún material para ello.
Ok, decirle que con mucho gusto, que les
Ah,
compartiré, dale,
¿ok? ¿Cómo?
con mucho gusto.
Ok. He said that he will share with all of you.
Mhm.
Les compartiré el Excel,
Okay. He will share with all of you the Excel
además de la presentación detallada del procesamiento de ese Excel.
and additionally the presentation for the correction for that Excel.
Okay.
El único detalle es que está en español.
But The detail is in Spanish.
No problem, no problem. We have ChatGPT. I would say we can just chuck some of the matter into ChatGPT to translate. I would say, I guess.
Okay.
Yeah, yeah, and yeah. Also, if you have any books or PDF recommendations on the SP, because that would be very nice to for us to learn as well.
Ok, menciona que si tienes algunos PDFs o algo que les podrías compartir para ellos, que sean muy buenos sobre CP.
Sí, de hecho, les sugiero el libro de Andrés Reville, que aborda toda la temática de potencial a nivel teórico.
I suggest to you a book written by Andre Repeal, and that book uh, have a lot about the theoretical things about SP, and he will share with all of you.
Okay, neat. Yeah. Okay, cool. Muy bien. Thank you so much. Is there any last question for Diego for the from the students before we what we call that? Oh yeah, so this is appreciation from us from the geophysical engineering a certificate for Diego. So you may want to screenshot this one before we separate for your documentations. Yeah.
Thank
Yep. Yeah,
Ah,
thank you so. Yeah, muchas
Muchas gracias
gracias.
por toda la invitación. Ha sido un honor, a pesar de la dificultad del idioma.
Mhm.
Thanks for the
Ellos,
invitation. And this is an honor for me. Unless the
Yeah, sure. And let me ask with the admin. Do we need to take a photograph together in the Zoom? So it's like
Yes, yes.
yes, okay, cool. So please for the attendants to turn on the camera. So we would like to take screenshot of all of us for the for our documentation as well. Yep. Okay. Could you turn on the camera, please? For everybody in the meeting? Okay, cool.